everyone, myself Bhumi Patel, Assistant Professor at LG Institute of Engineering and Technology in the Department of Instrumentation and Control. Today's our topic is fuzzy logic in the unit number 4, fuzzy logic application in the different control system. So first of all, we know about what is the fuzzy logic and at which application fuzzy logic is applicable. So first of all, the fuzzy word means the things that are not clear. Sometimes we cannot decide in real life that the given problem or the statement is either true and false. For that, we are using a different types of fuzzy logic method to find out the actual output of this particular system. So at that time, this concept provides many values between the true and false and gives the flexibility to find the best solution to that problem. Example is like that. Suppose we are using a temperature controller system. We can set the high and the low temperature for this particular system. Suppose high temperature is 100 degrees Celsius and the low temperature is 25 degrees Celsius. Okay, so the output will be on when the temperature will become high value or the low value. But between this value, that means if we can get the temperature at 50 degree. So what is the status of the output for this particular temperature then? For that we can provide the solution using the fuzzy logic. As you study in the digital logic design, we have used a Boolean algebra to find out the different state of this particular system. But in the digital system, we have only two states, 0 and the 1 state, or that means low state or the high state. But if we can get the value between 0 and 1, if we can get the value 0.6, then what is the actual status for this particular system? That is find out using the fuzzy logic basic. So fuzzy logic is very important to find out the value between the true or false condition or low to high value, and it gives the flexibility to find out the best solution for this particular based system. Okay, so example of fuzzy logic as comparing to the Boolean logic. So here simple example is given. Is it hot water? If there is a hot water, we have two options whenever we deal with the Boolean logic. If yes, then the output will be on, and if no, that time the output goes off. But the second condition is that is it hot water? So we have different possibility. It is very much hot water, little hot water, very less hot water, cold water. So we have different possibility for this particular example. So here three value is given. For the very much hot water, suppose the value is 0.9, little hot water 0.25, and very less it is 0.1. So if we know about that the actual condition of the water for this particular time or the throughout the system, at that time we can use the fuzzy logic. So what is the disadvantages of the Boolean algebra? Using the Boolean logic, we can only identify that the system is given is perfectly on or perfectly off. But using the fuzzy logic, we can easily identify the state between the true or false condition or the low or high condition or 0 or 1 condition. So this is the main advantage is that time we can use the fuzzy logic in these many control system. Okay, so next one is fuzzy logic contains the multiple logical values, and these values are the truth value of the variable or the problem between 0 and 1. As you know, between 0 and 1 there are number of different possible values there. Suppose 0.1, 0.2, 0.3 up to 0.9. Okay, so we have multiple possibility between the value of 0 and 1. So fuzzy logic give the multiple value for this particular system. So in the Boolean system only two possibilities there, as we discussed earlier, 0 and 1, where 1 denoted the absolute truth value and 0 denoted the absolute false value. But what about the value between 0 and 1? So but in the fuzzy system there are multiple possibility that is present between the 0 and 1, which are partially false or the partially true, depend upon the system output, system controller and the system input. We can easily identify that the value between 0 and 1, which are partially false or partially true for this particular system. Okay, so the fuzzy logic can be implemented in the system such as microcontroller, workstation based or the large network based system for achieving the defined output. So generally fuzzy logic can be implemented where the output value is between these two values or the output is given in the range. That time we can prefer fuzzy logic instead of the Boolean logic. As you noted that the Boolean logic is the not proper method for this system, that is not true. It is depend upon the plant or the system which logic is better for this particular plant. Okay, so it can also implemented in both hardware as well as software, and for that we have defined the fuzzy logic in different characteristics, because we have deal with the different plant in the control system. So depending upon the output we have defined the fuzzy logic with the different characteristics. So this concept is flexible and we can easily understand and implement it. So it is used for helping the minimization of the logics created by the human. So it is the best method for finding the solution of those problems which are not suitable for the approximating or the uncertain reasoning. So in the fuzzy logic everything is a matter of degree. So in the fuzzy logic any system which is logical can be easily fuzzified. So the first compulsory condition for the fuzzy logic is the system is logical. So it is based on the natural language processing and it is also allows user to integrate with the programming. So this is all about the fuzzy logic classification. Now the next one is the architecture of the fuzzy logic system. Okay, so how the fuzzy logic is work? So in the architecture of the fuzzy logic system, each component plays an important role. The architecture consists of the different four components which are given below. The first component is the rule-based fuzzy logic. The second one is the fuzzification. The third one is the interface engine, and the fourth one is the defuzzification. So there are main four components which are used in the fuzzy logic architecture, each which its own important roles. So we have studied one by one. So first of all, what is the actual block diagram or actual logic behind the fuzzy logic? So here the block diagram of the fuzzy logic system is given. Crisp input is applied to the fuzzification. Now what is the crisp input? So that we have studied detail after this block diagram. So input is given to the fuzzified system, then fuzzy input set to the given to the integrants, and then whatever output is there that is going to the defuzzification, and then we can get the crisp output. Between the fuzzification and refuzzification. If any rule is applicable for this particular plant, we can apply this rule. So first of all, we have studied about what is the rule-based fuzzy logic. So generally, rule-based is a component used for storing the set of rules, and then if then condition given by the expect are used for controlling the decision making system. So generally rule-based components are using the set of rules that is used in the programming. Suppose the program is like that, if this condition is satisfied, then go through the another condition. If not satisfied, then go out of the program. So if else condition, if then condition, for loop, that time we can use the rule based fuzzy logic. There are so many updates that comes in the fuzzy theory, which offers effective method for designing and tuning of the fuzzy controller. So these updates or development decrease the number of fuzzy set of the rules. Okay, so this is all about the rule base. Now what is the fuzzification? Fuzzification is the module or the component for transforming the system inputs. That means it converts this crisp number into the fuzzy set, because as you remember that fuzzy logic diagram, we have applied the crisp input. So the fuzzification is convert this crisp number into the fuzzy step. Then these crisp numbers are those inputs which are measured by the sensors, and then fuzzification pass them into the control system for the further processing. So these crisp number are those inputs which are measured by the sensors. Okay, sensors are generally connected in the system with the feedback element, and then this output of the sensor is fuzzification, pass them into the control system for the further processing. So these components divide the input signal into the following 5 states in any fuzzy logic system. So this is all about the fuzzification. Now the fuzzification are divided into 5 steps: large positive, medium positive, small, medium negative, and large negative. So depending upon the control output and the input, the fuzzification are classified into 5 steps: large positive, medium positive, small, medium negative, and the large negative. Clear? Now the next one is the interface engine. It allows the user to find the matching degree between the current fuzzy input and the rule based fuzzy logic. So it is the between theory between the fuzzification and the defuzzification. Now what is the function of defuzzification? So defuzzification is a module or the component which takes the fuzzy set inputs generated by the interface engine and then transform into the crisp value. So here you can see that in the block diagram, whatever input is given to the fuzzification, it convert into the module with the integrants, and then output of the integrants, fuzzy output set, is given to the defuzzification, and then output of the defuzzification in the types of crisp output. Okay, so it is the last step in the process of the fuzzy logic system. Okay, so using the different step of the fuzzy logic, we can identify the value between the true and false. So this is the main criteria whenever we use a fuzzy logic theorem. Okay, in the next session we will study about how fuzzy logic will be implemented for this particular system input. Thank you everyone. If anyone have doubt, then contact me in my email ID.